Start.
Awesome. Hi, everyone. Okay. Hi, everyone. This is Scaling Team with Microfrontends. Let us begin. So let's imagine that you have been hired as the VP of Engineering for Frontend at X, right? Your job is to increase the iteration speed of the dev team so that the products can rapidly evolve into something that is loved by everyone while generating ad revenue for decades to come. So now you do a review, right? X has a lot of features. It has timeline, search, messaging, communities, etc. With every one of these being complex enough to require its own dev team. So you're looking at having a dev team per branch of the product, right? Because X has like hundreds of engineers, and you want to figure out the best way to leverage this number of engineers and have them all work together. So now you have a problem, right? These teams need to collaborate because if they're going to build something cohesive, there has to be collaboration. And collaboration means communication. And communication gets harder the more number of people you have trying to communicate. See, if you have like 10 plus teams, this could easily grind to a halt if you're not careful. So you can have like see the number of communication lines from one team to the other. Now, structuring communication among teams across teams is very hard, and sometimes you have teams fighting one another, because of politics, and teams that require fostering to keep communication lines open, and if there is no fostering, they have like zero communication going on. Now, there's this concept called Conway's Law that says that businesses will create organizational systems that closely mirror the way they communicate internally, which means that if an organization is split into fragments of people who don't really communicate, then that's going to be what the organizational system is going to look like. Now, many organizations fight this law, but recently we've had organizations start leaning into it, figuring out how do we communicate internally and how can we leverage that to create an organizational system that works for us. And that is where microfrontends come in. So when you want to bypass the problem of managing communication among teams to build cohesive front-end products, and you want to squeeze out maximum performance from them, so you want all of these teams to work in parallel towards building the same products. That's when you use microfrontends. So microfrontends are for companies that have given up on communication. And so I am Michael. My name is Michael Ikechi. I am a software engineer. I designed and maintained Microfrontend system for used by about 13 teams for 2 years. Um, so to prepare for this talk, I built a small demo of Microfrontend for the X platform. So uh, we can see on the screen there are the different borders on the UI are showing the different apps that are managing these sections. So on the left, you have the home button. It has a kind of purple, background, and then there's also a purple, sorry, not background, border. There's also a purple border on the post button, and then there's this big purple border on this big main page. That shows that these two buttons and this big main page are all managed by the same app, and it's a different app that manages the Explore. That this Explore, this search, and this WhatsApp is managed by a separate app called Explore. Notification just manages this button, and there's messages, communities, verified. So you have 6 different apps on this page. Actually, it's 7 because there's one app that hosts all of these 6 to give us this cohesive experience. And we can see this URL. You can visit this. I'll just give like 10 seconds so you can copy it and look at any of these will take you to the app. So you can just copy it if you want to check it out, because I will not show this again. Maybe I'll post about it again soon, but like if you want to check it out, this is your opportunity. Um, okay, so let's go. So now let's talk about microfrontends. What exactly are microfrontends? A microfrontend is just an app that is capable of being loaded and rendered within another app at runtime. Now, most of the time when we're working with JavaScript, we are dealing with build time binding, right? Where you have things like import something from something. Now, this is ES6 import syntax, and this is happening at build time, which means that this import happens when you run your compiler. So you do npm start, or you use Webpack, or you do same npm start and you say VT or whatever your bundler is, right? That's when this happens. But we've always had ways to load behavior at runtime. For instance, with a script tag, it's a very simple HTML script tag. You pass in a source into it, and you can change the source at any time, and it just works. It goes and fetches the scripts, and then the scripts can run, and you have different behaviors. There's the require function that comes from CommonJS that has the same behavior, right? You can just pass something into it, an arbitrary string, and you get some value. Um, the iframe too does the same thing. You pass in any URL into it, and it loads that and shows you that. Um, oh, thank you. Someone posted this. So one more way to load the behavior at runtime is something called modal federation. And it's a mechanism that was started by Webpack and is now being adopted by other bundlers such as VT and the rest. And what it does is it lets you share code between applications by exposing modules at runtime. So the system that does this. And with module federation, you can specify the files with exports that you want to expose and give them friendly names. So you see on the right here, this is an example of how to use module federation, right? So in my application, I'm saying, okay, I have these files that I want to export to anyone who wants to use them. This is the name of my app. So you have name equals package name, where the package name comes from the package JSON. And then when you want to access any of these files, I want to have one file that can tell Webpack where to find these files. So that's what the file name is. So file name is remote entry.js. So anyone who wants to use any of my exposed logic within my app can just load the remote entry.js as a script on their page, and then they will have access to my modules. Now, what are these modules? That's where expose is coming. So all of these, the properties, all the property values, that's where you have source / nav home, these are pointing to actual files in my code, right? And then of course because these parts can get really long, you want a simple name for them. So what I have on the left is a simple name for them. And I call these models. So the name is scope. So let's remember that. The first one is a scope, which is the common name for my application. The second one is an entry, right? An entry, that's file name, an entry, the way for us to discover all the different modules we want to export. And the last one are the modules, right? So scope, entry, modules, we have to remember this because they're going to be very important. Now, this is the way to use module federation. So we've talked about how to export it. Now, how do you use it? On the app that's about to use it, let's call that the chassis app because it's chassis, that's loading other things, right? So this will create its own module federation plugin and say, this is the remote I want to use. So it has app one being the scope. So app one at the entry. So the entry is the path to the remote entry that was created on the micro frontend, right? Now, what we have here, right, is static loading. Um, it's static loading because this happens at build time. This is a Webpack config, so you can't have this be dynamic. That means that if you have these multiple teams, someone has to have the job of managing this. And that's not something we want. What we want is for it to be dynamic. We don't want to have anyone whose job it is to manage these entries all the time, because what that creates is a bottleneck, and that's something you don't want. The entire goal of Microfrontend is to give teams independence, but we'll see that come up more and more during this talk. So now as the VP of engineering, let's discuss ideals. What are the ideals you want to look forward, you expect from a solution that helps you solve this problem, right? The first ideal we want is well-defined boundaries, because our UI is complex, right? And we want to have, because we have different teams, we want to see this team owns this, that team owns that. How do we do that? So the first thing we want is well-defined boundaries. And this means that we are going to have a team-wide discussion and say, this is this part of the UI, this is what it means, this is the domains. We are borrowing this concept of domains from microservices and domain-driven design, where you have business domains for different parts of the business. So we have to categorize our UI into domains, and we choose a team that is going to manage that in perpetuity. So the first thing you want to keep in mind is that when you're doing this, is that team independence is a goal. If you come up with a solution that couples two different teams together, you don't want that. You want teams to be as independent as possible, so they don't talk to each other. There's no need for them to collaborate. They don't just run in parallel. So you have to keep that in mind when doing this. So now let's say the team has met and we've identified the 6 domains in the XUI, right? You have timeline, you have explore, notifications, messages, communications, verification, right? And they all manage different parts of the UI. Now, sometimes it's straightforward, sometimes it's not. For instance, this post widget here, which is the regular post widget, has a subscribe button. See, has a subscribe button just right there. Like you've chosen that, you have verified handles things such as, subscribe to premium and everything about verification and subscriptions. But then you have a subscribe button in here. So who owns what? So this now tells us that it should be possible for micro-frontends to host other micro-frontends. So that's something that's something we have to keep in mind, that there isn't just one single chassis. Any micro-frontend can be a chassis if you have that kind of tree structure, right? So let's keep going. Now our next ideal is we want to be able to automatically discover and launch micro frontends. Remember when I showed you this static way of loading micro frontends, and I said that this is not ideal because we want to have the discovery and launching of micro frontends be as dynamic as possible. So now let's talk about dynamically loaded micro frontends, right? You have the chassis in this app at the very top, at the top of the hierarchy. And then you have the different micro frontends. So the chassis will find these micro frontends. So it's able to host them, and it's like load as many of them as possible as we want in the system. So what we want is an abstraction that makes this possible. Now, what is this abstraction? The way I found to do this is something called slots. Now, the explanation for slots is that a chassis app has slots that can be filled by micro-frontends. And in turn, the micro-frontends tell us which slots they can fill. So you have that concept. The chassis says, I have these slots, these blank spaces that I want someone to fill. And the micro-frontends go and say, yeah, I can fill these slots. So you have a way to match these two together. And so that's how it works. So what is the nature of these slots? So I've talked about how slots are blank spaces. So let's see, what are examples of them? One of them is the route slots, right? Because you have routes that need to be filled by content. So for instance, /users, who's going to manage /users? So there is a users micro-frontend now, for example, right? Or /users/user ID, where user ID is a placeholder. So you have a profile micro-frontend that says, hey, I can do that. I can manage that, right? Or you have slash payments slash star. That's everything under slash payments. Who's going to handle that? The payments micro front end handles that. So that's the way route slots work. Now for non-route slots are things that do not live on the routes. They live directly on HTML elements within the page. So for example, in the layouts, we have nav slots. So in the nav slots, we say which micro front end can fill the nav slot. And micro front end say, hey, I can fill the nav slots. That's what I can do. And then you load every micro front end that can fill the nav slots. So unlike route slots, we are loading the first micro front end that can fill it. In this one, you are loading every possible micro front end that can fill a non-route slot. That's the difference between them. So now to facilitate all this, how does this work? Every micro frontend publishes something called a manifest. A manifest is basically JSON content that tells us which slots they have the ability to fill. So this is an example of a manifest on the right. So microfrontend-manifest.json, right? Where we have the scope, we have the model, we have the entry. We talked about these. We have events. Then we have slots. So these are the different slots that they have. One of them is the route slots. We're not really touching route slots in this point, but they're just like the others. So let's go to the others. Now we have the nav column item slots, which has a name, a module which points to the file that was exposed, and a priority. So what exactly is happening here? When we have a nav item to fill, we would say, who has a nav item slot? We'll search through all the manifests for a micro frontend that has that, pull it out, find their modules. Of course, we can get their scope, their entry, their module. That's what we need to load them, and we load them. Okay, so this is what the Webpack JSON looks like on the left, right? That's why the Webpack config looks like on the left. So you have the name, file name, and name is the scope. The file name is the entry, and exposes are the modules, right? So this tells us what how we translate into the manifests on the right. So now, how does the chassis know how to import the code exposed by the micro frontends? If we use an export default component like we have on the lower left, then the chassis will need to know how to mount and unmount the components. And this is restrictive, and it hampers independence. So for instance, say you have export default and you export a React app. What if the chassis was written in Vue and it doesn't know React? It has to learn how to mount React components. And how does it know it's React? Things like that. And if we use export const components, then there's also the problem of how does the chassis know what the name of the export is, because that's what this is a named export. So the way I found to do that and to abstract, one, the mechanism behind the behavior, that's whether it's React, Vue, Angular, and two, whatever is in named components and stuff, just do an export default and export an object that just has a very simple interface. It has a mount and unmount properties, where these are both functions. Now, functions are beautiful in the sense that they can encapsulate a lot of behavior. Now, because you just have a mount function that has a simple interface, whether it's React, it's Angular, it's Vue, whatever it is, that powers the mounting of behavior onto an element while passing props down into that behavior, is encapsulated for you, right? And the same thing too with unmounting. So you could even have, you say you're not using any framework, just want to just put an inner HTML that's powered by something as weird as Alpine.js and HTMX. That's a new thing on Twitter these days. So you want to do that, you can do that. And all you have to do to unmount it is just delete all the inner HTML when you're done. Okay, so yeah, these are the different frameworks you can possibly load. So let's review our ideals again. Right. First thing is we want well-defined boundaries. And we've talked about how having a team-wide meeting is the way to do that. The next thing is we want to automatically discover and launch micro frontends, right? And we've discussed the concepts of chassis, manifests, slots, and having a common interface. The third ideal is we want to share a framework and its dependencies. So in the previous two slides, we talked about how it's possible to use any framework. Now, do we want our teams to use any framework? Because you have told teams that, yo, you guys are independent, do whatever you want. They will do whatever they want, and it will shock you. So you want to have some kind of restrictions, right? And there are advantages to it too. So if you look at the right here, this is part of the Model Federation plugins config, where you can say, these are my shared dependencies. Now, what this means is that React DOM, React Router, and React Query of a specific version will be shared across the different apps. So if the chassis is using React, then every microcontroller that uses React does not need to download React anymore. And same thing for React DOM, same thing for React Router DOM, and for React Query. You only download them once on the page. Now, if they use a different version, right, then you're going to run into problems, which means we have to keep their versions in sync. You won't run into problems. You just download a different version of React and use that, right, for that micro front end. So if a team decides that they want to use Angular, for instance, right, then how do you enforce that they don't? One way I found to do that was to have bundle size budgets per team. So you tell every team, hey, this is an arbitrary number, give it a number, say 500 kilobytes. Your micro frontends bundle size must not go above 500 kilobytes. If it goes above it, you have to fix it and bring it back down. Whatever happens, right? So now that becomes a way to enforce it, because now if they add Angular is huge. It's going to ship with all of the stuff that you need. So everyone, you can use these constraints, you can have their freedom and independence within these constraints. So the fourth ideal is we want to be able to communicate among or across micro frontend, which means when something happens in one part of the UI, it should be able to affect another part of the UI, even if they're not in the same app. They are like different apps managed by different teams. And one of the ways I've found to do that is using event emitters or event buses. So on the page, you have an event emitter, which means a micro front end can emit an event, another one can listen to it. So we have timeline refresh happens here, and there's a trigger pull down. That's when the user has pulled down to refresh the timeline. Now, what happens? Another part of the UI can listen to it and say, hey, the timeline has refreshed. Maybe I should go refetch all my data, right? And these are two different micro frontends, it's two different parts of the page behaving, like working together, you know. And how does that work? That works with by publishing the event as part of the manifest. That's something you can do. So if you publish that as part of the manifest, then you can now have teams look at the available manifest and say what events are available that we can consume and make use of. So teams still remain independent. There's still little collaboration among the teams, right? Now, what I did to facilitate this was we had an internal tool called the Microfrontend Explorer that basically give a nice UI for looking at the different manifests, right? So to tell you there is this event owned by this team, that event owned by that team. You can look at them and say, hey, yeah, this is a nice event. I can make use of this event to do what I want in my microfrontend. Now the fifth ideal is microfrontends may require user authorization. So you have and this makes complete sense, right? Because you don't want the user to even know that a microfrontend exists. They don't have the right to use it. Say a user is not verified, they shouldn't even know that the verified tab exists, right? Because that's they are not verified. Why should they even know it's there? So that means that the software that aggregates the manifest and sends it down. Now that could be an API. An API is a very good way to do it, right? It means every micro frontend in its CI step would have to publish its manifest to the API and say, hey, this is the new copy of my manifests. Now the thing that's um, returns these manifests down to the front, then we need to look at the user's permissions and say, does the user have the permissions to view these micro frontends, right? I like this syntax for managing permissions. You have like manage slash me slash timeline, read slash me slash verified, and it helps you use things like path to regex, like the tools to like match these two things together. Our sixth ideal is that microfrontends need to access authenticated APIs. And this makes complete sense, right? How do you handle login and logout and making sure that microfrontends can fetch information with, say, an API key or a JWT, things like that? Now, if you start passing in these authentication details into the micro frontends, then you're spreading these things across multiple apps. You don't want them then spread. You want one app to manage authentication. And what I found works is just passing in a function, a fetch function. And that fetch function can have all the authentication information encapsulated within it. So your microfrontend is just receiving fetch from above and making its request to the APIs with that fetch function, right? It doesn't need to know how the fetch function works. All it knows is that it receives it, like for instance on the right here, it's receiving it from a used micro-frontend context, receiving information, like using it. Okay, so we want isolated micro-frontend styles. This is a big one. And it's a big one because styling across micro-frontend is hard, very hard. You have one way I've found to do it is to have nested CSS, like we have on the left, where you say this micro frontend has a scope timeline, and every micro frontend in my demo has these attributes, right? Data, ML, scope. So it can be timeline, explorer, whatever. And if you use this as a nested the CSS block to create your styles, then you can have style isolation. It's just going to be within that micro frontend. But personally, I like to use Tailwind. So with Tailwind, it's a lot harder. In my demo, I cheated. So I just copied a Tailwind CD and I put it in the chassis and was like, that's it. I did not like have to do to remove I'm sorry, give me a word. To remove unwanted styles and stuff like that. But when I had to do this at work, this was like I had to find a way to make it work. And the way I found to make it work was in the chassis, we would purge all unwanted styles, all styles that are not used. And we did that by a combination of looking at the purge CSS that has a way to look at your HTML. We would also make heavy use of storybooks to make sure that we can render all components in their different states, save these snapshots, like these two snapshot files, and then have Purge CSS inspect those snapshot files to find out all the different styles that have been used, so we know which ones are not used. So we use that to purge it. Then we would, in every micro frontend, we'll do the same thing too. So purge all unwanted styles. Now, if you just load these styles to the page, it would work to an extent, but then you would have duplicate styles, like styles that have been used in both the chassis and the micro frontend, and that can create problems. So what we did was to diff the micro frontend styles against the chassis styles, and you have this kind of diff that goes on. So when every micro frontend loads, you know that it's loading with its own unique styles that are not in the chassis. And that's the way we got it to work, right? So this is one way I found to have Tailwind work with micro frontends. I haven't inspected any other CSS library, so I can't tell you how. But if they work similarly to Tailwind, like they're like with CSS libraries, then this should work too. Okay, now what's all the benefits of this? Now we've talked about the benefits to the company, right? The business, like, yeah, things are moving well. Teams are, moving in parallel. Um, we are getting outputs has output like 10 times. We are moving faster, all of that stuff. How about developers? What's the benefit for developers? Now they're no longer talking to their teammates across teams. There's like one, there's less meetings. See, if that's something you enjoy, less meetings like me, then that's a benefit of it. But one technical benefit are the benefits that come with loose coupling. And one of them for me is manifest overrides. Right. So now, because we know that microcontainers are loaded at runtime, and all we need is the manifest to load them, that means that where they come from really doesn't matter as long as the code is available to be loaded. This means that we can override the manifest for a specific micro frontend running in production, and maybe point it to like localhost or something, or some other domain that we control. Why would we do this? One reason is testing. Imagine you are working on your tiny micro-frontend apps. You're working on just the timeline, and you want to test that, right? You want to do an end-to-end test or whatever. Do you spin up the chassis and like 50 different micro-frontend apps together to test it? Because you need to test it end-to-end. How do you do that? And the ways these apps can get so complicated, it can be difficult to wrap your head around how to run all of them at the same time. So instead, you would, run your localhost app in production. It's running localhost, but running in production. And I did a small video of that on Twitter where I showed how I was editing something in my localhost. I would save, and then I would get Webpack's hot reload in github.io, which is basically my production of my demo app. Right. So like testings, that's one way to use to test your micro frontends. So the next one is that say you have a user who has run into some production bug and trying to figure it out. You want to reproduce the steps that the user has taken, then you can do the same thing too. Point that micro front end to your local hosts, and you get all the benefits of console logs and debuggers and all of that stuff right there in your IDE. And the advantage is you can point a micro frontend running in production to staging, so you can demo something that's happened or a bug has happened. One day, if a previous version of that micro frontend is stable enough, so you test that, right? Just point it to that previous version and you're good. Now, speaking of previous versions, another benefit of this is instant rollbacks. So let's say your team has an SLA, but you're always going to maintain the last 50 versions of your micro-frontend and apps in production, that's in the CDN, always. This means that when something happens, you deploy version 0.0.3 of the timeline micro frontend, and then something has broken. What do? You just click a button that makes a post request to the micro frontend manifest server, point it back to 0.0.2. And just like that, instantly you have a rollback that has worked, right? So instant rollbacks without having to set up Vercel and Netlify and all of that stuff. It just works. Okay, so now that we have all these benefits of loose coupling, we have instant rollbacks, we have manifest overrides. The question now comes up that do SPAs that use micro frontends still need to have the regular dev staging production gates and pipelines? Or can we just do with shipping to production directly? And what's the advantage of letting go of these pipelines? Personally, I feel like it's not. I feel like you could, with some creativity, just ship to production. But let me know what you think. All right, that's it. That's the end. Thank you very much.
Thank you, Michael. Thank you so much for your time. There was a question. We have a question. And I mean, if anyone else has a question, this is the time to ask before we go. So, question from the Q&A. From preventing teams from using, say, Angular, can we have a list of only permitted libraries / frameworks, and then no team can use any library that's not in that list? If we don't want to use the minimum threshold method.
Sure. That's something that works for your team. But something I found is that if you tell teams that they have independence, they will put that to the test, right? So you want to have technical reasons for not doing that. A very good technical reason is like, we want to have shared dependency. So things, we are only using React 18. That's what you're, using going forward, and that works. But what if a micro-frontend just serves a single button? Does it still need to use React? Can it just make you do with, some simple JavaScript that's not React? Things like that. So yeah, if that works for your team, I'm just telling them, we're using this version. That's good.
Okay.
But yeah, that would be my answer. Is there a way to? Okay, sure.
Is there a way to what?
Oh, I just reading the second question.
Okay,
Is
yeah.
there a
Is
way
there a way
to
to
handle?
handle dynamic rendering of micro-frontends?
Sure, that's what we talked about. Like this talk is about dynamic loading and rendering of micro frontends. There's this static method that's I talked about in one of the slides where you're managing it in your Webpack config. But this is about doing it dynamically. So you have your chassis would find all the micro frontends capable of filling a slot via the manifests, right? So to use the manifest, find out all these micro frontends and load them. And it needs three things to do that. It needs their scope, their entry, and the module that it needs to load. When it has these three things, it can load them, and these are dynamic values. So yeah.
Yeah, thank you. There are no more questions. So I think we can wrap it up there. So thank you so much, Michael. This was very insightful. Thanks for joining us at SysConf. We hope to see you again. Thank you so much. I think people can add questions to the Q&A. Like if you have extra questions, and Michael would check it out. So Michael, you can just check out the session. We'll keep it up.
All right.
People have extra Q&As, you can just answer them. All right. Thank you.
All right. Bye, everyone.